Hey everyone, this video is to talk about the trig functions. Now, from a beginner standpoint, you typically learn about the basic three trig functions. There are actually six, which we're going to focus on today. So the first thing that we need to understand are the different parts of a right triangle. So the first three that you have here, hypotenuse, opposite, and adjacent, these are ways that we label the three sides in our triangle. Theta is a Greek letter, kind of looks like a zero with a line through it, and that is the reference angle. Everything revolves around theta. And the important thing is that theta will determine or determines the opposite and the adjacent. So the first thing that you need to know, and this is what I train all my students to do, is when you see a right angle box, you draw an arrow to the side across from it, and that is always your hypotenuse. That's never changing. Hypotenuse is always across from the right angle. Now, if I were to put theta in this corner down here, that means the opposite would be the side that's across from the theta, and the adjacent would be next to it. The 90-degree angle can never be your theta, so theta is always made up of the hypotenuse and the adjacent. Now, if I were to switch this around and put my theta in the top corner, now this horizontal side is my opposite and the vertical side is my adjacent. What you'll notice, hypotenuse is never changing, but theta will determine where the opposite and the adjacent are. So we have our three main trig functions: sine, cosine, and tangent. So we abbreviate each of these, as you can always see the abbreviations on a calculator, with three letters: sine, cosine, and tangent. We do not call these sin, cos, and tan. Yes, that's how they look like they would be sounded out, but you still need to say the full name, not the abbreviation. So sine, cosine, tangent every single time. And your formula for these: sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. Now, you are expected to have these memorized and to know and understand them, which this may be review. We remember these using the word SOHCAHTOA. Now, the first way that I just wrote it is how I always write SOHCAHTOA. It does not matter which you want to do. I prefer this way because if you look at the three big letters, sine, cosine, tangent, and then you basically have your formulas embedded. Sine is O over H, opposite over hypotenuse. Cosine is A over H, adjacent over hypotenuse. Tangent, O over A, opposite over adjacent. If you write it this way, it's very visually appealing and helps you to really see those three formulas. So these are our main three. We also have three reciprocal functions. So if you remember, a reciprocal function is a function that when multiplied by the original, the result is 1. So for example, if I started with the number 2, the reciprocal of 2, you flip the numerator and the denominator, so it becomes 1 over 2. Because if you were to multiply 2 by 1/2, you would get 1. All right, so our reciprocal functions. Cosecant is the reciprocal of sine. Our abbreviation is CSC. Now think back to the word SOHCAHTOA. Sine is O over H. So for the reciprocal, you flip them. It's going to be H over O, hypotenuse over the opposite. For secant, that's a reciprocal of cosine, and it's SEC. Thinking of the word SOHCAHTOA, cosine is A over H, so this is H over A. And then cotangent is the reciprocal of tangent. Abbreviation is COT. With tangent, it's O over A. Here, it's A over O. Unlike our three main trig functions, you don't have a made-up word to help you. My recommendation is to know which function goes with which. So knowing that cosecant goes with sine, secant with cosine, cotangent with tangent. And that way, when you write out the word SOHCAHTOA, you can just flip the letters to help. Okay, so my first example, find the values of the 6 trig functions of the triangle. What you should notice right away is we are missing one of the sides of our triangle. I'm going to go through and I'm going to label first. So across from the 90-degree angle, that is our hypotenuse. 5 is next to theta, so that's going to be the adjacent. 12 is across from theta, so that's going to be our opposite. Now we need to find that missing side. In order to find the missing side in a right triangle, we want to use Pythagorean theorem. So that's a squared plus b squared equals c squared. We'll call this unknown side x, or leg squared plus leg squared equals hypotenuse squared. This is going to give us 25 plus 144 equals x squared, or x squared equals 169. Taking the square root, I'm going to get that this missing side is 13. So now I can go through and I can evaluate. So sine is the opposite over the hypotenuse. That's 12 over 13. We always try to simplify if we can. The reciprocal of sine is cosecant. So I flip the fraction. 12 over 13 becomes 13 over 12. Cosine, the adjacent over the hypotenuse, that's 5 over 13. Reciprocal of cosine is secant, so I flip it, it becomes 13 over 5. Tangent, the opposite over the adjacent, 12 over 5. Reciprocal cotangent is 5 over 12. The other type of example that we can see is given one of the trig functions. If I'm given sine of theta is 4 over 6, that can reduce sine of theta is 2 over 3. The only other one that I can figure out right now is the reciprocal, the cosecant. So instead of 2 over 3, it's 3 over 2. Now, the one thing that would make this a little bit easier is to draw a picture. I know I'm working with a right triangle. It does not matter which angle you choose to be theta. I'm going to choose this one and label my sides. This is my hypotenuse, my adjacent, and my opposite. So I'm given sine is 4 over 6. That's opposite over hypotenuse, 4 and 6. From here, you need to find the missing side. So the adjacent side, the unknown, is going to be x. That's leg squared plus leg squared equals hypotenuse squared. That's x squared plus 16 equals 36. X squared equals 20. Now, we need simplest radical form because 20 is not a perfect square. So the biggest perfect square that goes into 20 is 4. 4 times 5 will get you to 20. We do this because 4 is a perfect square, so it's 2 radical 5. And then we can finish out the rest. So cosine the adjacent over the hypotenuse. That's 2 radical 5 over 6. That's actually going to reduce down to radical 5 over 3. The reciprocal secant is 3 over radical 5. Huge red flag, we can't have a radical in the denominator, so we rationalize this. And it becomes 3 radical 5 over 5. And then lastly, tangent and cotangent. Tangent, the opposite over the adjacent, so that's 4 over 2 radical 5. Before I rationalize, I'm going to simplify that. So 4 divided by 2 is 2 over radical 5. I rationalize to get 2 radical 5 over 5. Now for cotangent, we know we need to just flip. You want to flip it at this stage before you've rationalized. Because if you do it at the stage after you've rationalized, you're going to have to rationalize again, which is just way too much work. So I flip 2 over radical 5 over 2.